Welcome to our channel Sankalp Study Success. Today in this video we are going to learn about pushdown automata. That means what is the pushdown automata and how are we going to solve the problems of pushdown automata. Here we are going to learn. So previously we have learned that for the context free language, the automata which is going to accept that context free language is nothing but this pushdown automata. So this pushdown automata is going to accept the languages of context free language. That means which is generated from the context free grammar. So now let us see what is pushdown automata and how are we going to define that pushdown automata. Here this pushdown automata, it is designed to accept context free language. This is the main purpose of the pushdown automaton. And this pushdown automata consists of three parts. That means the first one is the input tape. So let me draw here. It is an input tape where you are going to have your input strings in this, and you're going to have a finite control. The second one is finite control. And in this finite control, this is nothing but it is going to point any one of your input symbol. That means it is going to give the current input symbol. See here, this is the input tape and this is the finite control where it examines top of the stack and also the current symbol. See here, we have drawn only till here, so it is examining the current input symbol. And there is also a stack for us where this stack is nothing but we are going to store the values in this stack. So there is a stack here and it is going to point to the top of the stack. Okay, so that means this is the top of the stack. So finite control is going to examine the current input symbol and also the current top stack alphabet. Okay, so now this is nothing but the stack and this is the input tape and this is stack. So the pushdown automata consists of three different things, which are input tape, finite control and the stack. So here input tape is made up of several cells which consist of input string, and if you are going to have $B and also a B with a slant line, that means this B, then it is considered as the end of the string over there. If there is a string, that means A, B, B, and a B with a slanting line is followed by the string, that means till here we are going to end our string. It represents the end of the string. Okay, so here this is about the pushdown automata. And how do we define the pushdown automata is, it is with the 7 tuple notation. It is of 7 tuple, where this pushdown automata is Q sigma, where Q is the set of states and sigma is the input alphabet. We are going to have a stack alphabet here which is defined like this. It is a stack alphabet and a transition function. We are having the initial state, and here Z is nothing but the top of the stack, and also finally we are going to have the final state. So this is nothing but the 7 tuple notation where we are aware of what is set of states, input alphabet, transition function, initial state and final state with the 5 tuples. But the only thing is here we are having stack alphabet. It is a stack alphabet and this Z is nothing but top of stack. So this is our 7 tuple notation which is going to define our pushdown automaton. And now let us define the transition function. How are we going to define the transition function? Transition function maps from Q cross sigma union epsilon cross stack alphabet, which tends to Q cross stack alphabet whole asterisk. This is our transition function, and you need to remember this transition function because for the 2 marks question it may be asked in to define the pushdown automata. So if you define the 7 tuple notation and write what are those 7 tuples, then you should also write what is the transition function and how it is going to define it. So we are going to define our transition function as Q cross sigma union epsilon cross stack alphabet, which tends to Q cross stack alphabet whole asterisk. So that means here there are set of states. So from one state to another state, as we move, there is a change in the state, right? So sometimes in the push down automaton, there may be a change in the state or there may not be a change in the state. So here there is one more point where there might be change in the state or may not be change in the state. So now this is about the push down automata and how do we define the push down automata. Now let us see one more thing, which is the instantaneous description, which is the important thing. If you observe this instantaneous description, then you can easily write the moves or the transition functions. So it is nothing but instantaneous description. Okay, so it is instantaneous description. And also this instantaneous description is denoted by a symbol which is like this. This is the symbol of instantaneous description. So now this instantaneous description, it is nothing but it is a move in the push down automata. So that means from one state to another state, how are we going to move? That move is nothing but the instantaneous description. So for example, let me take transition function of q comma a comma y. Then you are going to get it as q1 comma xy. So if you see, observe this one, this is the one which I have taken, and if you observe this one, this is our current state, this is our current input symbol, and this is nothing but top of stack, correct? So we are going to have, because the transition function is defined like this, here you're going to have your state and then you're going to have the current input symbol and then the top of the stack. If there is no top of the stack, then we will use our epsilon, correct? So we are defining the transition function with the three, those are current state, current input symbol and top of the stack. Then you will get the next state. This is the next state. When you apply A to Q, then you are going to Q1, and then in the top of the stack there is a change where you have also added X here. That means there is a stack which is already having Y, and then you are going to add X. That means now our top of the stack is X, correct? So here only X is the top of the stack, not XY. Only X is top of stack here. In this way, we are going to define the instantaneous description. So here you may have change in the state or you may not have change in the state. And also you may have the change in the stack or you may not have the change in the stack. So there are 4 conditions, and also if there is a change in the stack, then that change may be you can push an element into the stack, the first one, and the second one is you can pop an element from the stack, and the third thing is you cannot change the stack. That is up to you. That means there are 5 conditions where you can change the stack by pushing or popping, and you cannot change the stack, and you can change the state or you can stay in the same state as well. So here if you observe, the second one is transition function of p, b and x. Let us write it here. Transition function of p, b and x, which gives q comma epsilon. That means what? Here from p state, if you apply b input symbol to the p state, then it is going to q. This is the meaning. And here X is the top of the stack and epsilon is nothing but removing one element. Epsilon indicates removing or popping one element. This is nothing but epsilon. Wherever you see epsilon, then you need to pop one element. As there is only one element in the stack and you are popping it, so you are left with epsilon. So this is the second case where you are popping the stack alphabet. And then if you take here, see here there is a change in the state and you are popping the element from the stack. That is the case. And here if you observe PBX, and I'm taking it as P epsilon only. That means if you apply B to P, there is no change in the state. So our state is same P, but our change in, there is a state change in the stack where you are popping X, so you are left with epsilon. So in this way we are going to take the instantaneous description, and these are nothing but the moves of push down automata. So if you are given the moves, then you're going to ask to check whether any string is valid to this or not. So then you are going to use this instantaneous description. And also, in order to draw the push down automata, you have to use this instantaneous description. So where this consists of input state, current input symbol, and also the current top of the stack. So this is nothing but the instantaneous description. And here, if you observe this, there is a current state P and it is pointing to the current input symbol A1. That means you can write it as transition of P1 comma A1. Sorry, it is not P1, which is P. So let us take it as P only. So transition from P comma A1, and also the top of stack is X. Then you are getting a move from P state, it is going to Q state, and our input symbol also changes to A2, and the top of the stack is A, which is nothing but A, Q comma A. So this is our instantaneous description from this diagram. So in this way we are going to take the instantaneous description. There is no need to draw the diagram again and again for each and everything, but it is just for our understanding, in order to know whether it is moving from one state to another state, or the top of stack is going to change from one element to another element or not. So now here we should also come to know whether how to draw the transition diagram for the push down automaton, correct? So for the push down automata, we are going to draw the transition diagram as, see, let me consider one of the instantaneous description, and then we are going to draw for that instantaneous description the transition diagram. So let me take transition of Q comma A comma Y, which is equals to P comma alpha. I'm taking it in this way. So there are two states, Q and P. So now let us draw Q and P as two states. Now we are going from Q to A by applying an input symbol, Q to P by applying an input symbol small a, correct? So by applying an input symbol small a, comma, because we are having only one input symbol, so comma, our top of the stack. So you need to write the top of the stack which we had, and present top of the stack also. So in this way we are going to draw the transition diagram, where we have to take the number of states and then the move from one state to another state by applying the input symbol, and also the changes in the top of the stacks. What is the previous top of the stack and what is the current top of the stack. So this is our transition diagram. Now let us solve one problem using this instantaneous description. So then we will be much more clear. Then you are going to understand the next topics, which are deterministic push down automata. It is the deterministic push down automaton. So in the how do we draw the deterministic push down automaton and all, we are going to see in our next topics. So let us solve one problem using this instantaneous description. This is the question which is given to us, where for the given push down automaton M. So this is our push down automaton, where Q0, Q1, Q2 are this set of states, and A, B, C are nothing but the sigma, which are the input symbols. That means the input alphabet, and A, B, Z0 is the stack alphabet, and this is the transition function as we know, and this is the initial state Q0, and Z0 is the top of the stack. This is nothing but the top of the stack, and Q2 is the final state. So we are going to close it here. So this is the 7 tuple notation, and this is the final state. So this is the 7 tuple notation which we have in our push down automaton. And for this push down automaton, they are also given with the moves, that means the instantaneous descriptions. Now what are we going to do now? Let us take any input string, which is, let me consider it as BB, ACA, BB. Okay, this is any input string which we can consider, and let us check whether this input string is going to be accepted by the push down automaton or it is not going to accept by the push down automaton. So now how we are going to check it? By using the instantaneous description, right? Because it starts from the initial state Q0 and our input string is BB. ACA BB is our input string, and our top of the stack is Z0, which is already given in the question. This is Q0 is the initial state and Z0 is the top of the stack. So then our instantaneous description, it is not equals to, we are going to denote with this symbol, and then see here our current state is Q0 and our current input symbol is B. By applying the top of the stack as Z0. So Q0 B Z0. Let us see here. There is a move here, Q0 B Z0. Then we are going to Q0 B Z0. So let us write it here. It is the transition function of Q0. We are already done with 1B. So let us write the remaining BA CA BB, and the top of the stack is BZ0. That means B is pushed into the stack, right? So now the current top of the stack is capital B. Now the instantaneous description here, the transition function of Q0 B and capital B here. So let us see whether there is a move or not. Q0 B and capital B. See here, Q0 B and capital B is equals to Q0 comma BB. So it is moving again to the Q0 only, and we are left with ACA BB. So the top of the stack is again BB. That means you are pushing one more B inside. So BB Z0. Now our current move is Q0 A and B, right? Because A is the input symbol which we are applying to Q0 and the top of the stack is B. So Q0 A B. So our instantaneous description of Q0 A B, is there any move or not? Q0 A and B. For transition function of Q0 A and B, here we are having Q0 comma AB, where A is the top of the stack. So Q0, and we are remained with CABB, and here what is the top of the stack here? AB. So let me write A here, because the top of the stack is again we are pushing an element A, so it becomes ABBZ0. You can also write a single A, there is no difference, and if you write the complete thing also there is no difference, but you need to remember the leftmost one is nothing but the top of the stack. Not every element are the top of the stack. Now we are going to check whether there is a move of Q0 C and A. So because the C is the current input symbol, so transition of Q0 C and A. There is a move here where transition of Q0 C and A will give Q1 comma A. So we are going to change the state from Q0 to Q1, and the remaining string is ABB, and here we are going to have A as the top of the stack. So that means for ABB we are going to have A, BB and Z0. Because we are already having A, there is no difference in the change, there is no change in the top of the stack, so we are having A itself. Now we are going to check whether there is a move for Q1 A and capital A. So let me check Q1 small a and capital A. Yes, there is a move here, but our move is Q1 comma epsilon. Here epsilon is nothing but popping one element from the stack, correct? From the stack, which element do you pop? Stack is nothing but it follows LIFO principle, right? Last in and first out principle. So what is the last in that you need to remove first? So for this our move is Q1 comma epsilon. So we are in the same state Q1 and we are left with BB, and this A was the last in, right? So we are going to remove that A. We are left with BB Z0. Now we need to check whether there is a move from Q1 B and capital B. So here Q1 small b and capital B. Yes, there is a move here, and again our move is Q1 comma epsilon. So let us write it here. Transition function of Q1 comma, we are left with 1B, and for epsilon, that means we are going to remove again another B, because this is the top of the stack right now. So last and first out will be removed. So we are left with capital B Z0. Now we need to check whether there is a move for Q1 B and capital B, which is the same move again, Q1 B and capital B, which is Q1 comma epsilon. So which is Q1. We are not going to remain with anything, so epsilon. In the top of the stack we are having epsilon, right? So epsilon means you are going to remove B, so you are left with Z0. So let us check whether there is a move for Q1 epsilon and Z0. See, last one is the move for Q1 epsilon and Z0. For this Q1 epsilon and Z0, the move is Q2 comma Z0, where Q2 is the final state. So Q2 comma Z0. Here we have reached to the final state. So by processing each and every input symbol which we have in our input string, we have reached from the initial state to the final state. So we can say that therefore the given input string is valid. So one more thing, when are we going to say that the given input string is valid? There are two conditions here. There are 2 points. You can have acceptance by final state. Acceptance by final state. And one more thing is acceptance by empty stack. Acceptance by empty stack. That means if you are going to process from the initial state to final state by processing each and every input symbol, then you can say that it is acceptance by final state. Or if you are going to have that means you are processing from the initial state and you are processing each and every input symbol which you have in your input string, but you are ended up with the empty stack. That means in the stack there is no element in the stack, it is an empty one. If you are ending up with the empty stack also, then you can say that it is accepted by empty stack, and you can say that the given string is a valid string for the pushdown automaton. So in the 2 ways you can say that the given pushdown automaton is valid. The first one is by acceptance by the final state, and the second one is acceptance by empty stack. So this is about the pushdown automaton and the instantaneous description. In the next video, we are going to learn about deterministic pushdown automaton. And also will solve the problems related to deterministic pushdown automaton, where these problems are the most important problems for our external exams. So thank you for watching the video.